Happy birthday to me. Happy birthday to me. Happy birthday to me. Happy birthday to me. Happy birthday. Hello, my dears. Now, is it actually my birthday? No. Your girl's a proud Libra, but it might as well be, because this just might be my favorite class of the entire year. In it, I finally get to show you one of my favorite things in algebra. In class 3.9, we're talking about the quadratic formula. So, in a way, I like to think of solving a quadratic equation like picking a lock. We've studied their anatomy, what they look like, where they come from, and how we can break them down. And in so doing, that's given us a bunch of different tools to use as our lockpicks. Namely, right, we've got 4 different strategies for solving an equation that we've encountered thus far. What are those methods? Take 30 seconds, look back in your notes. What are the tools in my toolkit that I know that can help me solve a quadratic equation? Go. Alrighty, well, back in Unit 6, we began by talking about square roots as inverses of our exponents. So square roots connected to the idea of solving using inverse operations was the first method that we saw for getting rid of some exponents and isolating our variable. Then in Unit 7, right, we talked about this skill extensively called factoring. And we know that when connected with the 0 property, if I can get a 0 on one side, factor the other, I can set each of my factors to 0 individually. Then in Unit 8, we tackled the visual dimension in the form of graphing. And as we generated our graphs, we noticed that solving our equations using either inverse operations or the 0 property was connected to the process of identifying the x-intercepts of our graph. And last but not least, last time in Unit 9, we identified a 4th and final way, not really final, right, but final so far, to identify our solution sets, and that was by completing the square. If I could get a perfect square trinomial containing my variable on one side of my equation, then I could take square roots and solve for my variable just as I normally would. But since when has good enough ever been good enough for us? Just like any mathematician, why should we care about these lockpicks? Instead, why don't we just blow that lock wide open? Which introduces for us the tool to end all tools. We're calling it the quadratic formula. And this incredibly useful discovery takes its power from the ability to reveal the solutions to any equation in standard form. Right? Our ax squared plus bx plus c equals 0, that standard form that we've become familiar with. Now I'll write it out for you. And then the exciting part comes from showing why it makes sense and where it comes from. The quadratic formula, given an equation ax squared plus bx plus c equals 0, is as follows. We say that x, the value of our variable, will be equal to negative b plus or minus the square root of b squared minus 4ac all over the denominator 2a, where a, b, and c, right, are the coefficients there in my standard form ax squared plus bx plus c equals 0. Now, I could just give this to you, but it's way more important for us to know, well, where the heck is this guy coming from? So say that I take my standard form. There's a method to the madness here. Where are we coming from last time? What do you think I might be able to do to this standard form to create my quadratic formula? Take a risk, take a chance, make a guess. 10 seconds. Go. Five, four, three, two, one. Well, if you guessed that I, just like last time, might be able to solve this equation by completing the square and building myself a perfect square trinomial containing that x, then you are right on the money. Now, I'm not necessarily expecting you to be able to reproduce this, but I am going to derive for you, which means show you right where it comes from, the quadratic formula by completing the square on this standard form equation, ax squared plus bx plus c equals 0. Now, if I'm thinking through my procedure, you might even want to pull it up on your own. The first thing that we want to do when completing the square, we want to get all of our variable stuff to one side and our number stuff to the other. Well, the only thing here that is not attached to x is c, so let me begin by subtracting c from both sides. Now, I have ax squared plus bx is equal to negative c. Step 2, my leading coefficient when I'm completing the square needs to be 1. So to make my leading coefficient 1, I need to divide that ax squared by a. But if I divide one thing by a, everything in my equation must be divided by a. So ax squared divided by a leaves me with x squared. Bx divided by a, I'm going to write as b over a times x, where b over a is some number. And then I have negative c over a, which I will leave as negative c over a. Now I know that I need to complete the square, which means I need to turn x squared plus b over a x into a perfect square trinomial. In order to do that, I need to take my middle coefficient, b over a, and begin by dividing it by 2, right? This is the process for building our perfect square trinomial. So I'm going to start by dividing it by 2. Remember that dividing by 2 is the same as multiplying by 1/2. b over a times 1 over 2. Numerators times numerators, denominators times denominators should be b over 2a. Last move in completing the square, I'm going to square this guy, right? I divide by 2 and then square. In the top, remember that I can square the numerator and denominator separately. b times b in the top gets me b squared. 2a times 2a in the bottom gets me 4a squared. This tells me if I want to build a perfect square trinomial on the left, I need to add b squared over 4a squared to the left. And if I do it on the left side, I've got to do it on the right side too. So now, my new left side is x squared plus b over ax plus b squared over 4a squared. And on the right, I'm just going to, for ease, write the b squared over 4a squared first and the minus c over a at the back. Now I know, because I completed the square, x squared plus b over ax plus b squared over 4a squared is a perfect square trinomial. In the front, x squared I know has to be x times x. Both of my signs here are positive, so it's going to get a plus in the middle. And now I need a number at the back that multiplies by itself to get b squared over 4a squared. Well, that is the number that we squared right over here. There's my b over 2a. If I do b over 2a plus b over 2a, that would get me 2b over 2a. Cancel out those 2's. That does give me the middle coefficient of b over a that I'm looking for. Nice! Now on the right, b squared over 4a squared minus ca. What if, just for fun, I decide to write this as a single fraction? Well, in order to write two fractions as a sum or a difference, I need a common denominator. What's the common denominator between these two fractions going to be? 5 seconds, go. 4, 3, 2, 1. Well, if I can turn a into 4a squared, then I can get a common denominator. So I need to multiply a by 4 to get to 4a squared, multiply the a by a to get my a squared part, and if I do it to the bottom of my fraction, I gotta do it to the top as well. So now, on the right side, I have my b squared over 4a squared, and then I'm subtracting 4a times c, which I'll write as 4ac, over 4a times a, which is 4a squared. And now I can combine those two fractions. They have the same denominator, so I'll combine their numerators. B squared minus 4ac over 4a squared. Hey, if I remember my quadratic formula, that b squared minus 4ac should look real familiar to me, which tells me that I'm on the right track. Now that I'm here, I have a perfect square on the left-hand side. Let's take the square root. On the left, the square and the square root cancel out. That leaves me with x plus b over 2a. And on the right, I can take the square root of the numerator and the denominator separately. So I'm going to take the square root of b squared minus 4ac and divide it by the square root of 4a squared. Now the x plus b over 2a, I can't do much with yet. The square root of b squared over 4ac, I can't do anything with that either. But look at that denominator. What times itself gets me 4a squared? Well, the square root of 4 is 2. The square root of a squared is a. And since I'm being really good, I've taken a square root. I'll add in a plus or minus. Now the only thing standing between me and my goal is that b over 2a. Well, let's subtract it from both sides. Now my x is all by itself. And on the right, I've got negative b over 2a. Remember, the convention is to write the plus or minus radical stuff after the stuff not containing any square roots. So I've got b squared minus 4ac inside of my square root all over 2a. And would you look at that? These fractions have the same denominator, which means that I can write their numerators in a single line. I've got that negative b from the first fraction, my plus or minus the square root of b squared minus 4ac from the fraction, and then all over that common denominator of 2a. Would you look at that? We have just shown where our quadratic formula comes from. Fantastic! So we've got this quadratic formula now, and now that we have it, that means that we can use it whenever we want. Eventually, we'll realize that even though we can, we might not always want to. But for now, let's see how and if it works in action. Here's our friend from last time and from class 9.1, x squared minus 2x equals 1. In our last class, we completed the square on this equation to show that its solution set was 1 plus or minus the square root of 2. Let's show that we get the same answer using the quadratic formula. Now, the quadratic formula only works when I'm in standard form. So my first move should be to write this guy in standard form. I need a 0 on one side, so this is x squared minus 2x minus 1 equals 0. Now for my quadratic formula. I need to identify my values of a, b, and c to substitute in. Well, in standard form, a is the leading coefficient. In this case, that invisible 1 is in front of x squared. B is my middle coefficient. Well, that's negative 2. And c is my constant term, which here is negative 1. All I need to do now is plug in to my quadratic formula, which is, say it with me, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I just need to do my substitution. Well, negative b would be negative negative 2, so this should be negative, negative 2, which will eventually switch over to positive 2. Now I've got plus or minus the square root of b squared, so that's negative 2 squared, minus 4, a is 1, and c is negative 1. And then I'm all over 2 times a, which is 2 times 1. Let's simplify. From here, negative, negative 2 we've established is positive 2, plus or minus the square root of negative 2 squared. Negative 2 times negative 2 is 4. And then I've got negative 4 times 1 times negative 1. That should get me positive 4. And all of this is over 2 times 1, which is 2. So I've got 2 plus or minus the square root of 4 plus 4, which is 8, all over 2. Well, look at that square root of 8. I know that I can take the square root of 8 and simplify it by identifying any factors that are perfect squares. 8 is 4 times 2, so the square root of 8 is the square root of 4 times the square root of 2. Now, the square root of 4 simplifies to 2. I just need to take that denominator of 2 and divide everything by 2. So 2 divided by 2 leaves me with 1. 2 root 2 divided by 2 would leave me with 1 root 2. So my final answer would be 1 plus or minus 1 root 2. I can leave that 1 invisible. And would you look at that, 1 plus or minus the square root of 2 is exactly the same as the solution set that we identified by completing the square.